Hello everyone, welcome to the lecture series of blockchain security. Myself M.Naveenraj, Assistant Professor, Department of CSE IoT. In today's class we are going to discuss about the public key cryptography because the public key cryptography is very useful in implementing blockchain security system. Okay, let's discuss about this. This public key cryptography is also known as asymmetric cryptography. It's a cryptographic system that uses two mathematically related keys. We all know that. One is public key and private key. That is, public key is a openly shared thing and private key will be kept secret. Okay. These keys are mathematically linked but computationally infeasible to derive one from the other. Okay, which is the major risk. Now, let us consider the mathematical foundation because this public cryptography is based on hard mathematical problems such as integer factorization problem, that is RSA. It is very easy to multiply two large primes but extremely difficult to factor the result. Okay. Similarly, discrete logarithm problem, Diffie, Hellman, that is ECC, which is very hard to reverse exponentiation, right? This ECC stands for elliptic curve problem. What it means, it uses points on curves. For every curve you will be having a points, okay? So which will be very secure with smaller key size. Okay, next we will move to the key generation process, which will be very important. Before communication the keys are generated. Before communication the keys are generated. The first step is select the mathematical parameters. Okay, then second step is generate private key, that is a random number will be generated. First will be select mathematical parameters, then second generate private keys, that is random number, then third is compute the public key using formula. Okay, for examples, let us take private keys as D, public key will be equal to D into G. Okay, where G is the elliptic curve point multiplication. Even if Q is known, finding that small d is almost impossible, right? Similarly, under the working mechanism, we will have some encryption process. The sender obtains receiver's public key. Okay, the sender obtains receiver's public key because I want to send some message. I need some mail ID of that particular person, right? Similarly, the sender obtains receiver's public key. The message is converted into numerical form. Okay, then the encryption algorithms applied. So this is how this working mechanism works. For example, we will give the code as cipher will be equal to encrypt of message comma public key. Okay, so the cipher text is transmitted. And similarly, the decryption process, the receiver applies, right? So message will be equal to decrypt of cipher comma private key. This is the code will be given, the original message is recovered. Okay, in that the next is authentication process, so which will be used in the public key for ensure sender identity as well as message integrity. Okay, next is signature creation. The message which is hash generated message will be encrypted using private key, then signature will be created. After that, we will go for verification. The receiver decrypts signature using public key that generates hash of received message. Compare the both hashes. If equal, then the validity is not equal, it will be tampered. Okay. So in real time examples like banking, the message is signed, that is private key, then encrypted, that is using public key. Okay, that is receiver's public key, you are using encryption. It provides CIA trait, that is confidentiality, integrity and authentication. Okay, then next is algorithms used here is RSA algorithm, reverse Hellman, based on prime factorization. It is widely used in SSL, TLS, email creations, etc. CECC also used, that elliptic curve cryptography, which is a smaller key size, the faster computation and will have high security. Example, you take 256-bit ECC, that will be 3072-bit RSA security. So this is what the great advantage which is used in all blockchain, Bitcoin, Ethereum, everywhere. Okay. Next is Diffie Hellman, that is purpose is using secure key exchange used to share some secret key over insecure channel. So this is what the various techniques which are used in the Republic. In the real life examples are banking system, HTTPs, email creation, digital certificates, Aadhaar, e-governance, and like various materials examples are there. So thank you.